Looks like a couple people more joined our event today. We're going to be taking about another 10 minutes before we get started. We had a lot of people sign up today, so we're just going to give them a chance to join. We'll get started here shortly. All right, again, welcome everybody to another live event. We are going to be going over some 3-axis stuff today. I know it says 3D CAD and CAM. Mostly it's going to be CAM, maybe take a look at a couple functions. So let's go ahead and get started here. Now this part I already have set up. I defined a fixture for it. I have my workpiece and I have my stock. So I'm going to go ahead and rough this thing out first, but I'm going to use some rest roughing. So I'm going to go down to my mill 3-axis, select geometry. I'll just turn off my feature here and pick everything. As always, whenever you're doing 3-axis, it's a good idea to pick your entire model so you don't crash into anything. We don't need a boundary for this. And I have my origin at the bottom of the part. That's why my top of features reading is 1 1/4. So I'm going to start out with a couple advanced roughs, and then we'll see what we need from there. So I have 2 advanced roughs here. I'll go ahead and hit next. I don't need anything on the posting page. Now I'm using a multi-axis machine, so I'm going to get my multi-axis posting page as well. I'm not going to be needing that for this today. And I'm going to go in with a 3/8 end mill. So we're going to rough it out with a 3/8, and then we're going to go with the rest rough with a 3/16. And again, because I do have a multi-axis machine selected, I do have the automatic 3+2 tilting in here if I needed. But we're not going to be using that today, so I'll hit next. Bear with me 1 second. All right, sorry about that. Now I'm going to go ahead and use the adaptive roughing function on this. We'll go next. Now in version 35, they did add a start point that you can add for the advanced rough, as well as a couple other tool paths. I don't need it for this one. There's really only 1 or 2 places it could start from. Depth of cut, let's just go ahead and go with like an 1/8 inch, and step over we'll do something a little bigger. Let's go 200. Now I'm not going to set a lot of these other little things like the number intermediate steps. I may come back to that. I'm going to keep this pretty basic, straightforward at first. Now my minimal curvature radius is set to 40 thou. If I want to have larger arcs, this is the minimum that the adaptive toolpath will do. If I can extend that. Let's make that 62.5. Let's make that a 16th. That means it won't allow that tool to make anything smaller than a 16th radius. Now, when you're using the adaptive, you have your ramp, but you only have line and spiral, and it's just automatic if it needs. But you do have a vertical lead out or vertical arc. The vertical arc is just going to do a radius. I believe it's 50% of your tool's step over, if I'm not mistaken. Now I'm going to turn on machine flatlands just so it can add an extra pass to get the floor if need be. Not going to worry about the rest of these settings here. Then we have our linking. I'm going to do direct within a group and retract on the exit between groups, so I don't crash into anything. We have our gouge check, our advanced feed rates, and our MDI, which is new to 35. If any of you guys are not familiar with that, now you can put in palette changes, things like that. Then my second advanced rough. Let's go with a 3/16 tool. Oh, let me double check the corner radius. I might have made it. Yet I did. That would have not worked. All right, so we're going with 3/16 flat end mill for the finish, for the rest roughing, I'm sorry. I don't need the tool axis control. We're going to go for adaptive roughing again. And this time the depth of cut, let's just go with an 1/8 inch, and step over, let's do 100 thou. And minimal curvature radius, this is a little smaller tool, so let's go with 32 thou. Leads, I'll do the same thing. I'll have it ramp automatic, and I'll do a vertical arc coming out. And if any time during the event, if any of you guys have any questions, feel free to type them out in the questions box. If they get a little too specific, though, we might suggest online training to cover them. Now, the options. This page is important on this secondary advanced rough. I want to turn on the rest roughing function. And we're actually going to come back to this because if I remember right, it doesn't really fully do what I want it to do. So we're going to play around with some stuff. Now, I don't really need the rest of this. So I'm going to go ahead and hit compute, and we're going to see what we got. And like I said, if anybody has any questions throughout the event, please ask. We'll have some time kind of reserved at the end to field any questions. All right. So let's go ahead and blank this out. So that first advanced rough is kind of doing what I expect. And the second one is just getting the remainder, which is good. That's kind of what we want. So let's go ahead and simulate that. Could have sworn that actually connected before. To double check that. We may go down to an 1/8 inch. Now, one of the really nice things in 35, once we load the simulation, which I don't know why it's taking so long to load. Once we load the simulation, we can actually keep it open. Now, I don't have mine opening in the separate window, but you can by going up to Settings and User Interface, CAM, and then you have the simulation window you can set to Embedded, which is what I have right now, and I can't change it to separate window because I have simulation currently open. So I'm going to slow this down a little bit. Kind of zoom in and take a look at this. Actually, we'll speed it up a little. Now there's the 3/16. And I think I am going to change it to an 1/8. I think that's the way to get here. But you'll notice that it's really not getting all of this either. And if that ever happens to you, there's actually a really simple way to fix it. The other thing I'm seeing is if I go to visibility, I'm going to turn on my workpiece, go back up to visibility and make my stock transparent. And I can see I got a lot of material for that finish tool to come in. So I'm going to remove some extra material in there. So let's go ahead and edit this feature. And mostly I want to change stuff on the finish, the secondary one. So I'm going to just go down to the tool. Let's change this to an 1/8. And the other thing we wanted to do is get rid of some of the excess materials. That's going to be this intermediate steps. So I went back up to the advanced rough, the first one, on the parameters page. I'm going to tell it I want 8 passes and detect anything bigger than, let's say, 40 thousandths. So any stock bigger than 40 thou, it's going to get this cut. To come down to parameters on the secondary one, and I'm going to add the same thing, but it's doing a lot less. So I'm going to tell it 2 passes and do the same 40 thou sticker, detect the stock thicker than, if I could speak. So let's go ahead and compute since we changed both of those. And while this is calculating, one of the things about this particular shape, when we get to look at the finishes, if any of you guys have already used some of the 3-axis or have been to any of the other events, we usually go through what those toolpaths do, kind of how they function. And if you've watched one of those, you'll know that a lot of those toolpaths really don't cut this type of organic shape very well. Sometimes you'll get some odd toolpath patterns, some weird cusp heights. You have tools to kind of help mitigate some of that, but it can be quite difficult at times. And actually, we have a site. Oh, I already closed it. See if I could pull it up here. And that's really mostly what we're going to take a look at today is some of these toolpaths that may be beneficial. While this loads, I can pull this up. Things like flow line, this odd shape here, using equidistant, it really doesn't do very well. It leaves you with some odd cut patterns, but flow line really kind of smooths it out. And I think there's actually better ones for that. Morph between 2 surfaces, using planar versus morph between, you can actually have it kind of streamline through that whole channel. You can kind of see the difference between the step overs. And then deburring, we're going to look at if we have time toward the end of the event. And again, if anybody has any questions or anything throughout, just type them up in the little questions box and we'll touch on them as soon as we can. Now, when we get to the finishes, what we're going to do is use some of the multi-axis toolpaths. We have a couple of them that we can use that'll do this really well. I know it's boring watching all this toolpath calculate, but I promise all the other paths are a lot faster. This currently is Pro toolpaths. The ones that we're going to be using to finish it are the Premium. You do get the advanced rough with rest roughing in the Pro. And if any of you guys weren't here when I first loaded it up, loaded the meeting up, we are looking at just 3-axis, so it's not specific to Pro, Premium, or Standard. Mostly it's going to be Pro and Premium. All right, so that should be done. So now the 1/8 inch, it does connect a lot better. And now this 3/8 is actually going up that wall a little bit. So what I'm going to do for the rest of this, let's go ahead and go to my settings. I'm going to change so that I could use the separate window here. When using that separate window option on your simulation, you can actually leave the simulation open so you only load it that one time, and you don't have to keep reloading it every time you open the simulation. Oh, okay, it is a separate window. Perfect. It just loaded in the exact same spot. All right, so there's my simulation in full screen. Good. Zoom into our part here, and let's make our stock show. Now we've already seen that first advanced rough, but I want to get towards the end of it, so I'm just going to take my progress, drag it kind of toward the end here. Now you can see where it's going to go up the walls here a little bit. We'll slow it down. So that's going back up the wall with those intermediate steps. Now the 1/8 inch really didn't quite get everything that we wanted. So again, we got to go back and adjust that a little bit. So I'm going to minimize the simulation, and you'll notice now it's just a little bar down in the bottom left-hand corner of my screen, because technically it's not a separate window in BobCAD, but it is part of the software still. So one really cool way that I can adjust that rest roughing is if I just turn off the use previous operation for the diameter, I'm going to change it to like 1/2 inch. That'll expand my rest area, so it'll expand what it's going to cut. I'll even add more for breakthrough amount. Now all I need to do is compute the secondary one. Yeah, actually this week they're running promotions on the 3 premium, so if any of you guys are looking to get it for the deburring or the surface-based toolpaths, now is probably a good time to check with your account manager. From what I remember, it's a pretty good deal this week on it. All right, so that expanded a lot more than I expected, and it actually did those intermediate steps up the wall. So I didn't need it to expand that much. So let's change that to like 400. Yeah, let's say 450. I don't think 400 is enough. I'm not sure why mine's taken so long to compute either. They should be hyper-threaded, so it's only calculating the changes. But it could be because I'm connected to the meeting. And I'm using my 3D mouse, and that's why I'm able to kind of rotate around while it's calculating. If you guys don't have one and do a lot of 3D work, I definitely recommend getting a 3D mouse. It makes your life a lot easier moving around apart. Once you get comfortable with it, that is. This advanced stuff is a pro feature, yes. It is a 3-axis pro feature. The toolpaths that we're going to take a look at after this are part of the premium package. Yeah, we wanted to keep this one a little bit more broad this week, so we can cover multiple 3-axis tools. All right, so that expanded the amount that I wanted it to. That looks like it did, at least. Let's go ahead and run the simulation. So I have the simulation open, but if I minimize it, I'm just going to hit Start Simulation again. And because I'm using that separate window, the simulation should take a lot less time to process. And it should pop up when it's ready. Yeah, it's working on it. All right. We'll just go ahead and run. And actually, we could skip this first one. Let's hit the second one, let it load. We'll go from there. So this advanced rough, this is a 3-axis pro feature with the rest roughing. So you can do this if you only have 3-axis pro. And that gets rid of all that excess material. Expanding that rest area just kind of cleans that up for me. So I have a nice smoother area for my finish tool. I could adjust the amount for the intermediate steps, but I'm not going to go through that. We're going to kind of move on to the other tool paths that we're using here. I'm just going to go ahead and close my simulation. All right. So I don't want to create another 3-axis feature. I don't need to add to the one that I'm using. What I'm going to be doing is going to mill multi-axis. This is where you'll find all of your surface-based toolpaths. Now, all of these surface-based toolpaths, it looks like there's a lot of options here, but technically these are all the same. They're just different ways of applying geometry. The ones we're going to look at the most today is parallel to multiple curves and morph between two curves. These are the two that I use the most. So let's do the parallel to multiple curves. I want to do the walls. So again, we have our posting page, the multi-axis posting. I don't need either one of those. And then the tool, let's go ahead and make this we'll do an 1/8 inch ball on the whole thing for the finish. All right. So these do look a lot different when you're going to apply the geometry and everything. So the first thing I need to do is pick my edge curves. Now my edge curve is going to be that edge right there. So I'm going to be parallel to that edge. Now the drive surface is what I'm going to cut. So that's going to be those two surfaces. Now, I don't want to set anything else. I'm just going to go to my tool axis control and set this to 3 axis. Depending on what package you have, if you have 3 Premium, this will already be set. If you have 5 Pro or 5 Premium, you'll have to go in there and change it. So I'm going to hit Compute, and we'll just see what the toolpath looks like. Like I said, these take a lot less time to calculate. So the first thing I see is my rapids. These Premium toolpaths, you can control every movement. So I need to control that rapid first. I need to get that up out of there. So let's edit this tool. We'll go to my parameters, and I'm going to go to linking, or link. So I can have it use lead ins and lead outs, tell it where to approach and retract to, how it handles gaps along the cut, links between slices, so every single cut. And then you have your retracts down here. So I'm going to tell it, we're at 1.25 inch part, so this is a 1 inch from 0. So I'm going to bring this up to, now let's go like 1.5. I don't need to have it too crazy high. So I'll go ahead and hit OK, and then compute. So now I got that retract up and over the part. Now I may want to extend the tool off the end. So let's go ahead and take a look at doing that. And really I want to set everything I need first, and then I can actually take this toolpath and copy it to the other side. So we're going to do extend and trim. So when you turn these on, you want to click on the button, and this would be a tangential extension. This is along the cut direction, so there would be a tangent. So let's just do a percentage of tool diameter, let's say 100%. And I don't want any side extensions. So I'll hit OK, and then compute. So now I can see that tool is coming completely off that part, but I might want to do a lead in and lead out. What's really cool about these is I have the full control that I can go to my link page and tell it, yeah, I want to use a lead in. On the last exit, I'll use the lead out. But not only that, links between the slices, I can tell it to use the lead in and lead out. Now, the lead in and lead out is set down below. So I go to my default lead in and lead out, and then I have my arc. My tangential arc is the default. So let's just do a vertical tangent arc. I'll tell it that it's going to be maybe 50% of the tool diameter. And the arc sweep, let's just make that about 45 degrees. I don't need a full 90. And I'll copy that to the exit. And I'll hit OK. That OK button is a little tricky. And then I'll hit compute. So now on every single one of these moves, it should be doing a radius lead in and lead out. Let's see here. Yep, there it is. Little teeny arc move coming into it, because I did 50% of the tool diameter. You can go bigger than that, but that's all I did. Just that little bit of a radius. I can have this go zigzag. I can really do a lot of things with this toolpath. So maybe I want to take a look at what it looks like zigzag instead. Maybe give it a little smaller step over, and I think this one's pretty much cleaned up. So let's say we want to do 25 thou step over. Doing zigzag down that wall. Cleans it up quite nicely. Now you'll notice there are a couple of retracts. So those retracts are actually based on what it's doing on the link page. So if I go back to my parameters and go to links, on the links between slice, on a small move it's set to direct, but on the large move it's set to clearance area. And that's what we're actually seeing there. So if I switch this to direct, all of these retracts here should come down and just retract, not do a retract at all. It'll just link between the passes. And it is actually still doing, it looks like it's still doing that radius off the part. Yeah, even on the in-between slices. Yeah, it's still doing our arc. So after it's leaving, it's still doing a radius before linking. So I like that. I think that's a good path. Let's take a look at it in simulation first. Now I closed my simulation because I think it was messing with my 3D mouse. I have not used my 3D mouse since we've had the separate simulation window, so we'll see if it messes with me again. And again, if any of you guys have any questions about the toolpaths or any of these settings or anything, just let me know. It seems like simulation is going to be taking a while for me to load it today. There we go. All right, so we've already seen the first two. We just want to take a look at the parallel to multiple curves. So I'm going to click on that on my move list. Going to load us to that point in the simulation, because there may be some other things that we want to adjust. Slow it down just a hair. All right, so that's not bad. And it's getting that full radius down at the bottom. Now I can zoom in on this and it can refine a little bit as I go. So that's actually not too bad. I think I like that finish. So I'm going to take that toolpath and copy it to the other side. So I'll minimize my simulation. I'm going to right click on this feature and I'll go to copy. I'll right click on it again and go to paste. Now that I have it pasted in, if I expand the parallel to multiple curves, on these multi-axis features, you'll see geometry, gouge check surface, and axis control. I want to expand geometry. And then we have our drive surface, 2D containment, and edge curves. The edge curve is the edge that I'm going to be parallel to. And then the drive surface is what I want to cut. So I'll go ahead and compute this one. So now I have my two wall finishes here. And I'll even rename these. I'll just call it A and B. The reason I'm renaming these, if I want to change my order, and I'll rename the rough feature here. In our operations tree, which I have over on the right-hand side of my screen, if any of you guys are in 35, it starts out with your CAM tree over on the left. But right now, all I see is advanced rough, parallel to multiple curves, parallel to multiple curves. So I want to see a little bit more information than that. I want to see the feature name. And if you're like me and you rename your feature, what you want to do is go up to Settings, CAM, and then go to Operation Tree Display Feature Names. When I hit apply, now I can see rough, wall A, and wall B. Just helps for a little easier management. Now, if you rename the actual toolpath, like this advanced rough, then you won't need that setting. Now, the floor down the middle, one of the toolpaths that I do want to kind of show you guys that I didn't really plan on using this, but I want to use it anyways. It's one of these surface paths, and it's called Flowline. Flowline is a really good toolpath for just a quick and easy, smooth, surface-driven path. You really don't have to set much. It's just a drive surface. So I'm just going to pick this surface here. But the thing about the Flowline, let's set it to 3-axis and compute, is Flowline, it kind of works like planar if you've used planar in the 3-axis Pro. It's just doing a direction. It's not an offset of anything. It's just looking at the UV curve, the XY curve of that surface. And if you turn on wireframe, the W key, you can see that UV curve. That's what it's following right there. So Flowline, as nice as it is, and I know it's one that you'll hear Al DiPaolo talk about a lot, you'll see a lot in our documentations. It's a great toolpath if you have a simple surface like that, that might be complicated in 3-axis moves, but it's one flowing surface. Flowline is great for. But for things like this, I like to use the morph between toolpaths. So let's go ahead and delete that. Go back down to Mill Multi-Axis. And this one I'm going to use morph between two curves. And essentially it's kind of the same settings. So I'm going to go with the same tool. And technically for this one, I could probably go with my flat end mill. Let's do that. because this is just doing the floor. So my edge curves is I have one on one side, and my second is going to be on the other. And then my drive surface is going to be the floor. Now, let's go ahead and set the tool axis control to 3 and compute. There's one thing about this path that we're going to see right away that I need to blank the other two. If you notice, it is morphing between those two, and it looks really good doing so, but I used a flat end mill. So that flat end mill is cutting into this radius. So there's a trick that I use when I'm trying to stay within an area, is this area section here. The default type is this full avoid cuts at exact edges, which it is. It's not exactly on the surface edge, but it doesn't give you a lot of room there. But if I go to full start and end at exact surface edges, and you can see it's going to try to morph between the exact edges, it sounds like that would be a bad setting to use if I want to avoid that radius, but this has an add internal tool radius, so it's going to offset for the diameter or for the radius of that tool. So now that offset for everything, and it should be cutting right up to this line. Now I may want to look at this in simulation to see if that's good enough. I may want to do a ball and mill with tighter stepovers, and it may just barely fit through this section right there. Let's add an extension to this as well. So I'll go to my parameters, extend and trim, and this time I'll do 50% of the tool diameter. I don't need to do 100. Linking, it looked like it was linking fine. No, it's linking right through the part. So retracts, we'll make this 1.5 like we did the other. And I'll have it use a lead in and a lead out. We'll just change that default lead in and lead out to a vertical tangent arc. Maybe I'll say 100% of the tool radius, and we'll do 90 degree. I'm sorry, tool diameter. And compute. Oh, I wanted to set that to zigzag as well. Let's just go ahead and do that real fast. And we can actually do a bigger step over. Let's make it, let's do 60. Oh, double decimal. Now it is a morph, so the 60 is the maximum it's going to do. It will get as tight as it can to fit that tool in there. It's going to do the same number of passes from here all the way to the end. So there's no relinking or anything. So this one's really good for channels like this. And I may want that tool to come off 100% or maybe even a little extra just so that it's not turning on the material. All right, I think it loaded. Yep. All right, so let's go ahead and expand this guy and go down to the parallel to multiple curves. I want to see the morph between. So it actually changed my order because of the tools, and that's fine. But let's just look at that morph between two curves. If the flat end mill works, great. If not, I'll switch it to the ball. So we'll see that flat end mill come in here. Just finishing that floor. And I want to kind of see the transition between the wall and the floor. Yeah, that looks pretty decent. I think I'm okay with that. And if there's a little step there, what I can do is expand the parallel to multiple curves. Let's go ahead and copy this. paste it back in, and then the other side is going to be the other one. So we'll select our drive curve. Then we'll go in and set our first upper edge curve, and it doesn't matter which one you do, you just want to pick both your edges. And then we'll go ahead and compute. And I'll call this floor A and floor B. All right, so now that kind of gets me to our machining order. We've got our advanced roughs, which is fine. Then it's doing a morph between two curves. Then it switched to the parallel and then back to the morph between. So if I want to keep those tool numbers together, just going to take that floor and move it up. Now I could move both of these down at the same time as well. So if I want those to be last, I can move them. Nice thing is that this operations tree, I can even change diameters of tool, I can modify the tools, and calculate everything that applies to it. So a lot of new power with that operations tree. All right, so it seems like it loaded simulation. Nope, still loading. There we go. So let's watch just the whole thing, and I'm going to turn off the machine. We're just going to look at the workpiece in stock. I can run with the fixture, but I'm not going to. Like I said, if any of you guys have any questions, we'll probably go for another 30 minutes or so. I know it says 1 to 3. I like to give about 30 minutes for Q&A. So if any of you guys have any questions, we can touch on some stuff. That, and I think the office is a little quiet, so I bet a bunch of people have already gone home for the day. It's eerily quiet. Now we should see it go up those walls here in a second with that intermediate step. Which I use that intermediate step on a lot of stuff, just to clean up things that need it. Now our rest roughing. And I could probably use a much larger radius. I just don't know what that radius is down at the bottom. But I will show you guys a real fast way where we can check. And I'm also dealing with the model, and sometimes that can be kind of be a pain when you're dealing with the surface-based toolpaths. So we'll talk about a couple of the CAD functions real quick before we look at Deburr. So that doesn't look too bad. I don't think it's a bad transition between the two. I do see a dark line, but that could be the way that the graphics are showing it. So let's go ahead to analysis and change this to none. So we're just seeing the basic blue. So there is a little bit of a step there. I may want to use the ball and mill, or even let's double check our walls, because this could be a void. Yep, this is void exact edges. So let's do exact surface edges for both of these. And that may change the simulation enough. It may change the quality enough where we won't need to extend it out or anything. If not, I'll switch the other one to a ball. It's actually a very easy thing to do. which I may do anyways, just to show you guys how you can use this operations tree for quick stuff like that. Because it looks like it created 2 1/8" end mills anyways. One in the, probably one in the finish category and one in the rough category. Not quite sure. Oh, I know what it is. Because I copy and pasted the feature, and it has a different tool in there. It actually gave it a different tool number. It's something that I found pretty early on in 35. So if you're doing copy and pasting, it does actually generate a new tool when you paste it in, but it's easy to swap the tools back. I'll show you that. We'll change the tools and everything too. I really just want to see those finishes. So let's go ahead and just jump down to morph between 2 curves at the end, let it run, see what it all looks like. And it looks like it might have crashed over the top of the part. That might be one of my retracts. Might not have set it high enough. Oh yeah, that's perfect. Nice blend in between the two. So that is probably, yep, this secondary wall. Let's edit that. I didn't change the rapids. Probably because I didn't need to on the other. Oh no, I did. Let's change this to automatic. Oftentimes I'll use automatic, but oh, that's, okay, so I know what this is. This is a direct move that it's having a problem with. So in this particular case, the setting that I used on the first wall was fine. I could change this large move to direct. I need to now change that to either feed or rapid distance. Let's change our retract back to user defined to 1.5. So that's a situation where the gap was too big in that cut. And that probably just changed because I told it to do exact surface edges, because that section's a little wider. So that's probably why that did it. But that's not the end of the world. All right, now the middle section, I could actually take, now let's say I want to just switch this all to the ball and mill real fast, maybe change my tooling. Now, this wall is using a different tool than that wall, or than this floor. Yeah, this floor is a different tool. So I'm just going to drag this up to the other operation. Now it has a little flag on it. I can compute from there. But maybe I really just want those to be a ball and mill. I can actually take both of those operations and drag and drop them to my, oh, that's a 3/8 flat. There it is, okay. Drop that to those. And then I can actually compute all the tool paths that use that tool. And it only computes the ones that need to be computed. Now let's go ahead and change that floor. Since we changed it to a ball, I'm going to do the exact surface edges, and I'm just going to remove the internal tool radius. And we'll go down to a 25 thou step over like it is on the top. I can even change my walls now so they don't have such odd path. So we'll get rid of the internal tool radius, change our step over, and compute. Now that means I can change my walls to avoid cuts at exact edges, because that actually gave me a pretty decent cut where it wasn't doing some extra work. And that should get rid of this, because I don't believe we had that too much. Yeah, we had it, but it wasn't bad. So what we can do is on that wall, now I can switch it back to a direct link. And it just feeds across. So last but not least, the little island in the middle. And really, that's just another morph between two curves. I can actually just take the floor and go to copy and then paste. So it's another floor A. I'm just going to drag and drop that down. So it's at the bottom, and I'll rename it real fast. And then I'm just going in and selecting my drive surface, which is going to be all of these. And they do flow the entire length, so that should be good. And then my first upper edge. And again, it doesn't matter which one you're picking, as long as you're picking opposite edges. A lot of these, when you're using them for 3-axis, you can kind of copy and paste the toolpaths and they'll work out. Like this one, I might need to tighten up a little bit. Maybe go to like 10 thou. Just so I get a little better result on the top there. But the multi-axis are really great for this, those premium toolpaths. But the other thing that the premium toolpaths give you is the deburring. Now this already has a bunch of stuff on there. I'm going to go through adding the deburr, but I wanted to kind of go through each different type of deburr that you get. So you got your ball and mill. We can just minimize some of this. You have your lollipop cutters. You can do a different type of deburr. Your chamfer mill, which is newer to this version. So if you're on 34 and you have premium, you're not going to have that option. Ball mill spiral, this is actually a newer function. And then there's the contact point control. You can change how you're contacting with that tool. So if you're using like a straight end mill. So we'll take a look at each one of these in simulation. And then I'll go through how to add a deburr feature, a couple of different ways too, actually. So you can see, and let me start that over and slow it down. For a ball and mill, you're not going to get a lot of, it really just kissing right on the edge, right on the ball. Nothing too crazy. Speed it up a little bit. Same is going to be with the lollipop cutter, but the lollipop cutter, you can go down an edge. I'm actually surprised I didn't do that on this one. Chamfer mill, again, that's a new one for this year, but you can actually do that on all these. And then the spiral, which is a newer function too. It's going to step over and step down as it goes around. Yet unfortunately, the simulation runs kind of at a low resolution. And then lastly, you have your contact point. So you can actually set a contact point for going around a part. Once this automatically refines there, we should see a little better edge. Now, deburr is actually a really simple toolpath to use. Not a lot of selection, not a lot of things to know about it. So you can see kind of the differences there, all pretty much doing the same thing. Now, if I wanted to add a deburr to this, maybe I want to just deburr the whole thing. Let's turn all these off. Now, the deburr function is found under mill multi-axis. You'll see it here under deburr. Again, this is a premium toolpath. And let's go in with let's say on the first one we use a chamfer mill. And I'm going to add from the library. Let's just do actually the 1/8 inch one that they got is fine, 1/4 inch. Yeah, that'll work. All right. So for this one, you do pick the entire model. At least that's what I typically do. So you have your part surfaces. And then you do have an edge detection option for auto detect or user defined. And to be honest, I do the user defined. So when you're in the auto detection, you do have this advanced section. Again, I don't really use the auto. I've never had it give me the edges I want. So I've never really played around with that, but it looks like you can tell it to exclude sharp edges if you need to. Limit detection area by a certain specified height, so you could specify where on the model, and the minimal edge. But I want to do user-defined edges. And really the easiest way to do this is I could just pick these top surfaces. That should pick every edge. And some actually. So let's go back in there, because there's edge down the middle. We'll try loop selection. And we'll deselect some of these in the middle. So if you're not familiar with what I did a loop selection. So loop selection, I don't need that. If you right click on a solid model when you're in geometry selection mode, you get two options, constant Z or loop selection. Constant Z will give me everything on one Z plane. Loop selection allows me to go around and pick a specified loop. So when you do the loop, you pick the edge next to where you want to go to set the direction for that loop and how it follows. So that's got most of those. We'll do loop selection on this side, and I just want to deselect the middle again. Oh, there we go. I think I got all of them. And I'm not worried about the holes. We'll skip those. Help if I selected the loop on that one. All right, I think I've gotten all of my edges. Doesn't look like I'm leaving any out. Now, I might want to save this selection because that's kind of a lot of edges to pick. So if I go over to my selections, I'm just going to hit save. So that way, if I need to do this again, I just pick this selection and it picks all my edges. All right, so we got a constant width. Let's go ahead and make that, I don't know, 25 thou so we can see it. Inner corners, we're just going to do a relief. You can set an advanced relief. It's just going to do a little loop. Or not. You can use the option. I'm just going to do it with the loop. We're going to do one cut along the edge. We're not going to overlap anything. And the surface quality is fine. So then we've got tool axis control. So I'm going to go to 3-axis. You do also have your rotary 4+1, 3+2, and 5-axis simultaneous. So depending on what license you have, would change the axis there. But we're doing 3 today. And then we've got our clearances. The last page is your linking. I usually just leave it on user defined for the height. This uses the same linking functions as all the multi-axis ones do. So if you've used those before, it's the same rapid feed distance, the air safety move, and then your link, whether you're doing a clearance area or a blended spline. Let's go ahead and do the blended spline. So I'm going to go ahead and hit compute. Nope. That relief thing is not an option. So we'll just do that on trim. Yeah, I guess that makes sense because I'm using a chamfer mill. And like I said, if any of you guys have any questions, we'll probably change this up a couple times, add some things into it. But yeah, if any of you guys have any questions, we'll probably end a little bit earlier today. All right, so there's my Deburr. Let's go ahead and see what that looks like in simulation. All right. We'll just let it run since we can't really see it until after it's done anyways. So it looks like I did forget one or two pockets there, but that's all right. Now it's small enough where it's sometimes hard to see in simulation, but if I go to verification, I can zoom in and I can apply refine. Now you will get a little error message. It is refining it, but it's not working 100% correctly. And it did pick up these holes because they were on that seam. But all in all, that did pretty good. Now, if I was using a lollipop cutter, I can actually go down this wall there. Let's minimize our simulation there. So let's change this to a lollipop cutter. Looks like they already have one in here that'll work since we already have these toolpaths on it. Oh, actually, I want to make this as a new feature. So let's delete that. Let's make a new one. Deburr. And I want to use a lollipop cutter. All right, so part surfaces, again, I want to pick the whole thing. And I'm going to do user defined. And the user defined edges, I could pick my selection there. And I can actually go in and modify the selection. Maybe I don't want those holes. I'll add this in there. And then I'm also going to add these coming down the part. Now I'm not going to worry about the constant width. Let's just make that pretty predominant so we could see it, maybe like 40 thou. Tool axis we'll set to 3, and we'll just hit compute. Dan, that might be more specific to specific parts or toolpaths that you're using. That's something that we could always do, like in an online training. You know, we sell those 1 to 2 hour blocks. Um, that's something we can always address in there because, in my experience, there's nothing that does a lot of air cutting unless you're telling it to. So there might be a reason for it. There's ways to eliminate that, but it all depends on the specifics. So. Oh, no problem, Dan. So now that I use the lollipop cutter, we can see it going down those walls and kind of radiusing out. They made this one a little bigger, so we should be able to see it on all these edges. Yeah, we can see where it kind of went down the wall. And if I refine it, did I miss one? It is possible. Oh, there goes my BobCAD. Let's just pull that back up. These meetings do take a lot of resources. Let's just go ahead and reopen that part. All right, and I'm actually going to set my simulation back to an embedded window. With as nice it is having a separate window, I'm just kind of used to it being embedded. But that really does kind of cover everything that we were going to talk about today. If any of you guys have any questions, let me know. We'll be here for another 20, 30 minutes or so. If you don't have any questions, thank you guys for coming out. I'm going to be sending an email out probably on Friday when we come back to the office for the survey. And we look forward to having you guys in another event. Might as well pull one of these other ones up here. Which one was it? Yeah, so they even went through and kind of showed different ways of applying some of these tool paths. You have your advanced planar, which you lose a lot of tool path right in between there. Better, they say, equidistant, which, yeah, equidistant's great. You can use drive curves to try to tell it how to follow, but you're going to get this really weird tool pattern. And then they're showing like the best result is flow line. But to be honest, for me, I think that there's one better, and it's just morph between two curve. This just happened to be another one of these parts in this kind of series of part files here. Say a 1/2 inch ball. And the two curves that I picked kind of tell it which direction to go. And the nice thing about the morph between two curves is it is morphing. So in areas where it's diving down more, you can actually have it kind of increase the tool path a little bit. Where flow line, it's just doing a direct step over. The flow line's really nice for an easy, quick, tool path, but I still really like using the morph between two curves. If I set that to a zigzag. Oh, and I need to increase my rapid. But I do get a little bit more control over it with the morph between. Let's just say automatic. We'll do full start and end at exact edges and zigzag. With the morph, I'd get a more consistent step over as well, or a more consistent finish. I can adjust that. Step over, it's set to 50 as a default. Maybe go to like 15. But yeah, if you guys have any questions, feel free. We'll be here for another 15, 20 minutes or so. I'm going to step away from my computer for a moment. I will be right back to field any of those questions. All right, I am back. And like I said, if any of you guys have any questions, feel free to let me know. We're just going to be kind of hanging out for the rest of the event. Again, thank you guys for coming out. We enjoy having you come out to these and look forward to having you in the next one.